morning students. Today I will discuss about different types of purification of water. That means drinking water. So please come to the topic. Please put on a heading that purification of water. So this is the main topic. What are the different steps involved in the purification of water? So first of all, please put on a heading that methods or steps involved in purification of water. Okay, so please write down the first method, that is screening. So the first one is screening. By this method we actually separate the floating materials, and the next steps, that is plain sedimentation. So this is the second method by which we can differentiate the suspended particles. And the third thing, that is sedimentation aided with coagulation. So please write down the third step, that is sedimentation with coagulation. By this method we actually add some coagulants such as alum, and it helps the suspended particles to form a fluff particle. And the fourth thing or fourth step, that is filtration. The fourth step, that is filtration. The fifth one, that is disinfection. These steps I will discuss in my next videos, that is disinfection. And the next step, that is aeration. So please write down the next step, that is aeration. Step number 6, that is aeration. And in the next step, which involved in the purification of water, that is softening. So this is softening. And the next step is different types of treatments such as recarbonation, which I can write down as a miscellaneous, such as recarbonation, fluidization, etc. So these are the steps which are involved in the purification of water. Now, by these steps we can easily purify normal water into a drinking water. So first of all we will discuss the first step, that is screening. So please write down the screening. The screens are generally provided in front of the palms or the intakes of the wax so as to exclude the large sized particle. So please write down, screens are generally provided in front of the palms or intakes. In front of the palms or intakes wax so as to exclude the large sized particles. Okay, this is the main thing you have to know about the screening. And what are the large size particles? The particles are maybe debris, animals, trees, branches. So please write down, such as debris, animals, trees, branches, etc. So these are actually the materials which are separated from the raw water to purify. Now there are two types of screens available. There are two types of screens available for this purpose. The first one is coarse screen and second one is fine screens. So these types of screens are available for screening purpose. Now these coarse screens are actually trash rocks, are sometimes placed in front of the fine screens. Okay, so please write down, the coarse screens are actually trash rocks and the fine screens which are actually provided after the coarse screens. Now these fine screens are made of fine wire or perforated metal with the opening less than the 1 centimeter wide. So the opening of the fine screens, that is 1 centimeter wide. This is the important about the screening. Now these fine screens are sometimes set at an angle, and this angle is actually 45 degree to 60 degree. So please write down, the angles of screen bars are 45 to 60 By these angles, actually, the screening bars are set up to purify the floating materials or to separate the floating materials from the raw water. Now, these materials are collected sometimes by mechanical, and this is actually all about the screening. So, if we draw a figure of screen chamber, it may be like in this way. These are the screen bars of angle 45 to 60 and these are the floating materials by which it can be separated. So now please come to our next topic, that is plane sedimentation. So please write down the topic, that is plane sedimentation. So what is the sedimentation? Sedimentation means the suspended particles should be settled down. So in still water, the impurities tend to settle down under the gravity. Although in normal raw pipes they remain in suspension because of the turbulence of water. So here the main thing the main thing that is you have to remember is this action is due to gravity and it separates the suspended particles. This is the main thing of plane sedimentation tank. And what is the theory behind it? The first thing is the velocity of flow, which carries the particles horizontally, and the greater the flow area, lesser is the velocity. Hence, more easily the particle can settle down. So, what are the factors here for theory of sedimentation? What are the factors affecting theory of sedimentation? That is, first one is velocity of flow, which I have already discussed. And the second thing, that is the viscosity of water. It is also an important topic or important factor, that is viscosity of water. If the viscosity of water varies inversely with the temperature, so the warm water is less viscous and it has less resistance offered to the settlement. The next factor that involved mainly, that is size, shape and specific gravity of the particle. So please write down the third thing, that is size, shape and specific gravity of particle. It is also very much important. If the size is bigger, then it will settle down so quickly by the weight of its cell point. So this is also important, and from this criteria we can conclude by a law that is known as Stokes law. So please write down, that is Stokes law. It is very much important because the Stokes law describes the settling velocity of the particles. So suppose this is the sedimentation tank, and here is the horizontal flow of water, and this is inlet and this is outlet. So here particles will settle down by this way, and it can be removed by in this way. So here, what is the velocity of the particle settling? That means, which is known as settling velocity. The term is settling velocity of the particle, that is denoted as Vs. It is very much important. So this is described by the Stokes law. And what is Stokes law? It gives a mathematical derivation, that is Vs, that means settling velocity equals to small g by 18 into g minus 1 into d square by nu, where Vs is the settling velocity, g is the gravitational acceleration, g is the specific gravity of the particle, d is the dia of the particle, and nu is the kinematic viscosity of the liquid. And this equation is satisfied when d, that means dia of the particle, is less than 0.1 millimeter. So this is very much important as it describes the Stokes law. Okay. Now this Stokes law, on the basis of this Stokes law, we will do a problem. So please write down the problem on Stokes law. So please write down the problem. That is, find the settling velocity of a discrete particle in water under the condition of Reynolds number is less than 0.5 and the diameter of the and specific gravity of the particle is 5 into 10 to the power minus 3 centimeter and 2.65 respectively. Water temperature is 20 degrees centigrade and kinematic viscosity of the water at 20 degrees centigrade is 1.01 into 10 to the power minus 2 centimeter square per second. So, what are the data given in this problem? So, if we write down the given data, the first thing that is given as the specific gravity of the particle, that is 2.65, and the second thing is given, that is dia of the particle. dia of the particle is 5 into 10 to the power minus 3 centimeter. It means that if we convert it into millimeter, then it will be 0.05 millimeter. So this is the dia of the particle. And what is the kinematic viscosity? That is also given 1.01 into 10 to the power minus 2 centimeter square per second. This is denoted as capital G, this is denoted as D, and this is denoted as nu. Okay. And the last thing, that is G, that is gravity of acceleration, 9.81 centimeter square per second. Sorry, 9.81 meter per second is given. Now we will put this value in the equation. So what is the equation? Equation is ds equals to g by 18 g minus 1 d square by nu. Now if we put this value, then what will be the equation? The equation should be, this is meter, so if we convert it, then we will get, this is centimeter square per second. So 981 by 18, 2.65 minus 1 into 0.05 by 1.01 into 10 to the power minus 2. So this is the equation actually. It is a square. So this is the equation which we will get from this theory. Now if we put this value in a calculator, then you will get that the settling velocity Vs, that is equals to 0.22 centimeter per second. So if these values are given, then we can easily calculate the settling velocity as 0.22 centimeter per second. Now this is all about the plane sedimentation process. Okay, and in my next video I will discuss about the sedimentation tank and its principle. Thank you.